Hello everyone, welcome to the TSS. In this class, we are going to discuss about the model evaluation stage of data science life cycle project's life cycle, friends. So, before going to the topic, in the earlier class, we had developed one model, okay, to satisfy our requirement, that is to predict the tip based on the total bill. Okay, so how the model is going to predict the things, friends? Okay, so let us see the mathematics behind it. So the linear regression machine learning algorithm, we have this basic, friends, that is y is equal to mx plus c. This is the regression line equation. So generally we will take independent variables in the x axis and dependent variables on the y-axis. Okay, so independent variables, otherwise the other name for the independent variables are called predictor variables. Okay, so we had named it as PV. When you remember if you remember the last class, so we named it as PV, that is predictor variables on the x-axis. So it may be one variable or number of variables. Okay, so if it is one variable, this is the equation, friends. Okay, and if we have number of independent variables, then the equations will change. Okay, second order, third order, fourth order, those equations will come here. Some complexity will increase if you have multiple predictor variables. In our case, we need to predict the tip based on the total bill. Okay, so total bill is the criteria there, that is the predictor variable. So that's why we are taking a simple linear regression with only one predictor variable on the x-axis, and the tip is the dependent variable, that is called the target variable. Other name for dependent variable is target variable in our case, that is tip variable. So for each and every total bill, there is a tip value. Okay, so if you uh, 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 plot a graph, then it will the scatter points will come like this. Okay, so that we saw in the pair plot. If you want, you will refer back to the pair plot of total bill versus tip. Okay, now come to the machine learning part. So we want to detect tip based on the total bill. Then how we have the model will detect? So first we need to train the model by giving the training set. So training set data, that is we will both give the x value, that is a total bill, and the corresponding tip paid. So by giving the x the predictor variable and y the target variable, we are making the model to learn. So what the model will learn by x and y means it will learn the coefficient of x, that is the weight of x, that is m. How the model will learn m means by this formula, x minus x mean into y minus y mean. There is some dash on the top of the x and y, so that is y mean. Okay, divided by x minus x mean whole square. Mean means we have several values in the x variable, that is total bill variable. So if you calculate the mean of that total bill column, some value will come, and uh, we need to subtract each and every value of total bill with that mean. Okay, how many number? 244, I think. So for testing set we had given 183. So 183 numbers we need to uh, subtract it, like that y also. So this equation should be evaluated for all the entries, and at last we need to sum up for each and every value. So how much time it will take, think. So with the pen and paper it will take more than 3 to 4 hours. So that is the power of Python. It will do it in some microseconds, and it will come up with the m. So if the m value come up, it will learn the m from the training set. Then if m value came, then c is very easy. From simple mathematics, the c will be known. So the model learns m, the coefficient of x, and the c, the intercept of y. So in both it will learn. So in if we provide the test set data, then it will take that on the and the value and substitute it in the x, and the model already learns this m and c, so it will substitute those m and c here, and the equation it will calculate, and the corresponding y will come. That corresponding y is shown to us. So this is the predicted tip value for corresponding your x, that is total bill value provided in the testing set. So this is the background mathematics behind the logistic algorithm, friends. So for very much detailed explanation will take 2 to 3 hours, friends. I am only giving the outlines of the regression model, how the mathematics work behind the linear regression model. Okay, let's now go to the model evaluation stage. So let's switch to Jupyter Notebook, friends, here. So in the last class we had discussed all these details. So the model will learn m and c. Okay, so in which stage? In this stage. Okay, 134th cell, training the model. In this stage it will, we are providing training input and their corresponding x and y both will provide to learn, to train the model. So the model will learn from this data. Which parameters the model learns means the coefficient, that is otherwise called slope, m and c. Okay, intercept. After learning, so it will predict the things from test input, how for each of the test input it will take. So this is the, if the test input it says something total bill like say $30, it will substitute it in the y is equal to mx plus c. So m value known, c value known, the corresponding y it will give like this predictions. So we have always some difference for the actual value. So test output has the actual value 2, but the prediction is 2.3. So by calculating the m and c, the model learns the m and c and substitutes the coefficient. So it is here it has given the coefficient, that this is called the m value and this is the c value. It will substitute for every input testing value, and then it will calculate the y value, friends. Okay, so let us evaluate the model. So differences, how the predictions are going. So this stage is let us mark down stage 5 model evaluation. Okay, friends. Okay, so now let us make the predictions and the actuals in the 1df, so that in the side by side it is visibly good to see. Data frame of predictions, comma, columns is equal to what? Predictions. So let assign it to some x variable here and run it. So let us likewise do for actual. So actual we are having that in uh, test output, right? Test output variable we are having. So it is already a data frame. We have to convert it in uh, array. Okay, np array comma columns columns is equal to say actual value. Okay, then okay, so let us join x dot join y and store it in the z. So display the z. So this is the prediction, the model prediction, and but the actual value is 2. So 2 is the actual value, predicted is 2.3. So the difference is some 0.3. Let me make the difference also. So the difference okay, difference is equal to z of actual minus z of predictions. Okay, actual minus predictions, actual value minus predictions value. Actuals. Okay, so let us display z. Here you can see now actual is 2, but the prediction is greater, so the difference is 0.3 difference is there. And then like that actually is 3.27, prediction is 2.38. So it should the difference is 0.45. Okay, this much of value difference is there. So like that for every prediction, that means for given total bill, the actual is 2 but the prediction is 2.3. This is testing set. Okay, so how much accurately our model predicted, if you want to know. So there is from sklearn library, sklearn import r square from matrix. Okay, import r2 score. Okay, so print r2 score of the differences. Okay, that is predictions comma in which we are having this one. So x and y. Okay, so x and y, x comma y. So that it is point minus 0.233. Okay, it should be close to 1. Okay, so let us plot the graph between these two. uh, Say plt dot scatter plot of x, that means predictions minus test op. So this is the graph. Okay, graph between the predictions and the um, test set test OP. Okay, so it should come like a line. So both points should be in the form of straight line. Okay, so this is the score R2 score of the model. So we always have errors. Okay, this is the differences. Okay, so we are having the differences, how much difference will be there. So for that we have the formulas. Let it discuss that one here. Okay, so this is the formula for mean absolute error, mean squared error, root mean squared error. These are the linear regression model evolution metrics, friends. Okay, so let us do it. Let us do it. So um, print of matrix dot, okay, import matrix mean absolute error, one error will be there, and mean squared error is there. Okay, both errors we need to import. So after importing, just mean absolute, okay, we need to run it, mean absolute error of predictions, comma, what, test OP. So mean absolute error is this one. Okay, and then same like that we need to detect mean squared error. Okay, squared error of the these two, that is predicted target variable and the actual target variable. So how much error is there, it will show. So 1.35. So there is a difference between these two I will explain it. Okay, so after that, these are different methods of evaluation technique, friends. So this is np dot asqrt because we need to square it. So this is 1.16. See, these are all the mean absolute error, mean squared error, and the root mean squared error. What this means, here we have a difference between the predicted, yi means the actual value minus predicted value. We have an error. If say suppose if the total bill is $20, the tip actual tip given is say $5. For $20, $5 is the tip given, but our model predicted 4 instead of 5. Then how much difference is there? 1. Okay, for that particular instance. Okay, $20, 5 is the actual tip given, but our model predicted 4 instead of 5. Then what is the error there? Okay, so that means simple, 5 minus, that is the actual value, minus uh, 4. Okay, so the error is how much? 1 for that instance. Like that, for how many test rows we have given, say some 70 change, I think so. At 70 records it will check, see for corresponding total bill, I mean how much predicted to the actual to the predicted value difference. So it will goes on doing all these formulas here. So simply it is weak. So the mean absolute error method. This is the y. This is the prediction, actual prediction. This is the actual. So it will do all these calculations which we are seeing here automatically, and in within seconds it has come up and given the total absolute error, that is mean absolute error. Okay, so it mean means it will uh, find the mean error. Okay, so that's why the 1 by n comes up here, and then first it will calculate, then it will mean that one. Okay, and then mean squared error. So actual to the predicted divided by the 1 by n. Okay, so and the root means square also is, this is like that. Okay, so that's how it goes and performs all these things, right? So these are called the loss functions, and it should, the error should be minimum, friends. Okay, so this is how the model will work, friends, and with this uh, we had completed the data science life cycle with an example. Okay, so in the other class we will come up with some other topic. Till then, bye bye. It's Veera signing off.